You know, your heart is talking all the time, but it's speaking in a kind of secret language, a language made of electrical pulses, a rhythm that tells the story of your health. Today, we're going to learn how to decode it, to understand the amazing story it tells with every single beat.
So to even begin to understand this language, you got to ask the big question. How does the heart create this incredible, life-sustaining rhythm in the first place? Well, try to think of it less like a machine and more like a perfectly rehearsed orchestra conducting its very own electrical symphony, beat after beat after beat.
And in this symphony, there are two key players we need to meet. You've got the conductor, who of course sets the tempo, and then you have the orchestra, which plays the powerful music that keeps all of us alive.
Okay, so at the core of this whole thing are two totally different kinds of electrical signals. Over on the left, that's the signal from our conductor. These are special pacemaker cells that automatically, on their own, generate the beat. Then on the right, you see the signal from the musicians. These are the powerful muscle cells, and they just wait for the conductor's cue before they contract.
It's really a beautiful, simple sequence. The pacemaker cells fire off that initial spark. That's the command. And then, in response, that much larger group of muscle cells fires off its own signal, creating that powerful contraction that pumps blood through your body. So if you remember one thing, it's this. The conductor gives the command. The musicians play the note.
All right, so if the heart is an orchestra, how do we listen in? How do we actually read the sheet music for this performance? Well, that's where a fantastic tool comes into play.
It's called an electrocardiogram, or ECG. You might have also heard it called an EKG. It's a completely painless test that just listens to those electrical signals from the heart and translates them into a picture, a waveform. It basically gives us a direct window into the heart's performance.
And this is what that sheet music actually looks like. This single repeating pattern is the key to everything. Every single peak and every valley on this little graph has a very specific meaning, telling us one part of the story of a single heartbeat.
So let's break it down real quick. See that first little bump? That's called the P wave. That's our conductor's cue. It's the atria, the heart's upper chambers, contracting. Then comes that big dramatic spike, the QRS complex. That's the main event, the orchestra's powerful crescendo, when the ventricles contract. And finally, that last little wave, the T wave, that just shows the musicians resetting, getting ready for the very next beat.
But, what happens when the symphony goes wrong? When there's a wrong note, or maybe the rhythm just becomes chaotic? This is when the ECG goes from being interesting to being an absolutely essential diagnostic tool. You see, a healthy heart has a steady, predictable rhythm. It's like a metronome. But all sorts of things can cause that music to become dissonant, and those changes, they're written plainly in the ECG's sheet music for us to find.
And this just shows the difference so clearly. On the left, you've got a normal, steady rhythm. See how every beat looks the same and the spacing is totally regular? Now look at the right. Wow. The bass line is all shaky and the main beats are completely irregular. The orchestra is totally out of time.
This condition has a name. It's called atrial fibrillation. What's happening is that the conductor's cue, that P wave, is just lost in a storm of disorganized electrical noise in the atria. The orchestra, the ventricles, they try to keep up, but the result is just an inefficient, irregular beat.
Now here's another type of dissonance. Compare the normal rhythm on the left to the one on the right. You'll notice something's a little off. You can see the conductor's cue, that P wave, but then, sometimes, it's not followed by the orchestra's crescendo. A beat is simply dropped.
This is called a heart block, and it's really just a communication problem. The conductor is giving the signal, but for some reason, the message isn't getting through to the main orchestra every single time. It's like having a faulty wire between the conductor's podium and the musicians.
The ECG can also tell us if a part of the orchestra is playing way too loud. If a section of the heart muscle, like the left ventricle, gets enlarged from working too hard, its electrical signal gets bigger too. And on the ECG, that just translates to waves that look unusually tall or deep.
So, when the heart's music falls out of tune, what can actually be done? Well, fortunately, modern medicine has a whole toolkit to help restore that harmony.
The goal is always the same, to act as a maestro, to guide that orchestra back to its proper tempo and rhythm. But how is that actually done?
Well, doctors have several strategies. They can use medications to slow down a conductor that's going way too fast, or maybe to calm down musicians who are a little too excitable.
In cases of heart block, a pacemaker can be used to strengthen or even replace the signal. And sometimes they can use a controlled electrical shock to reset the entire rhythm, kind of like a conductor clapping their hands to get everyone back on the same beat.
The scale of this performance is, well, it's staggering, because over an average lifetime, your heart's symphony plays on with no intermissions for roughly this many beats.
3 billion times. Just think about that. It's an incredible silent performance happening inside you right now. By learning to read the sheet music of the ECG, we get a profound appreciation for this intricate symphony and a powerful tool for keeping it in perfect harmony. So think about that the next time you feel your pulse. What secret is your heart telling you?